Hi everyone, we are going to learn how to graph a quadratic, which is a parabola. Think of it as a smiley face or a sad face by using vertex form. So first of all, what does vertex form look like? So vertex form is y equals, or you could say f of x, a times x minus h squared plus k. Now you know that this is a quadratic or a parabola because it has that squared value right there. So we know that that's going to be that smiley face or sad face. So first of all, what do these letters stand for? Well, the H stands for the x value of the vertex. Now, where's the vertex? Well, again, our picture looks like this. Our vertex would be kind of where it turns from decreasing to increasing, or that lower value. Or if you can think about, it would be the max value right here. Okay, so we would have the point h comma k. Oopsie. That would be the vertex for both. So I've kind of given it away here. What does the k stand for? Well, the k, that stands for the y value of the vertex. Now, there is a term here, a, which we haven't talked about, and that's going to be called the leading coefficient. Now that value tells you how skinny or how wide, or is it sad face, or is it a wide sad face? So that's what that A value is going to do. So let's do a couple of examples here. See if you can find out what the vertex is going to be. So if I have something like f of x, which is the same thing as saying y equals 2x minus 3 squared plus 4. What would the vertex be of that particular graph? Well, if you said 3 comma 4, you are correct. Because remember, there's the minus there already, which gets a little bit confusing. And so the way I've taught it before is that if you see a minus 3 here, you just make it positive right here. And then you keep this exactly what it is. So that would be the vertex. All right, let's try another one, something maybe a little bit more challenging. What if I had y equals a negative 1/2 x plus 6 squared minus 2? What would the vertex be there? Again, remember, we are taking the opposite of this, which in this case is going to be a minus 6, and then you're keeping your minus 2. So that's your vertex. All right, now let's go ahead and let's take a little bit more time to talk about the leading coefficient and what it means. Okay, so I want to talk about the leading coefficient and what it means. So if your A value, if your A is greater than 1, you are going to have a happy face. If your A is less than, I should have said A is greater than 0 actually, because I'm just saying A is positive. If A is less than 0, meaning A is negative, we get a sad face. All right, now, what if A is equal to 5? That's going to be narrow. If A is equal to 1/2, that's going to be wide. So this would be a narrow for A equals 5, and A equals 1/2 would be wide. Similarly, if I had something like A equals negative 5, that would still be narrow, but it would be sad. All right, so we still have that narrow. What if A equals negative 1/2? Well, again, we still get wide, but it's going to be a sad face. So what should you take out of this slide? Well, you should be able to, leaving this slide, you should be able to find the vertex from looking at the opposite of this and the same as that, and then have a general idea of saying, oh, this is going to be narrow and happy. This is going to be sad and wide. Sad meaning an upside down parabola. All right, so let's go ahead and let's actually do this problem. And I'm going to write steps as we go. So the first step here, step 1, is going to be to find the vertex. Okay, so step 1 here, finding the vertex, well, that's going to be the opposite of -1 is 1, and then you keep this as 2. So find the vertex and even graph it. So my 1, 2 is right here. All right, step 2 is something we haven't talked about, but step 2 is going to be find the axis of symmetry and draw it. Okay, the axis of symmetry goes right through the vertex. What I mean by that is if you look at these parabolas, an axis of symmetry is where there's symmetry, where you could fold it and you get the same thing on both sides. So same thing here, your axis of symmetry is here because it's the same on both sides. Axis of symmetry is here, 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 and here. So finding this axis of symmetry, we know is going to be this right here. And what's the equation for that? That's going to be x equals 1. So that's going to be the same exact x value as your x value in the vertex. I'm going to say that one more time. The axis of symmetry is going to be the same exact x value as the x in your vertex. So that's going to be x equals h, right? Remember, this is your h comma k. All right, so that's step 1 and step 2. I'm going to erase these steps, so make sure you have these down. Next thing we're going to do is we're going to find another point. So that point is going to be found by just plugging in an x value that's really close to the vertex. All right, so let's go ahead with step 3. Plug in an x value close to the vertex and plot that point. Okay, so for example, I want to know what's going on when I plug in 2, because that x value is close to the vertex, that vertex being that red point. So I'm basically going to take 2 and I'm going to plug it in. Remember, anytime you plug in an x value into your equation, it spits out a y value. All right, so let's go ahead up to our equation. And instead of putting an x right here, I'm putting in a 2. So let's go ahead and simplify that. So we've got 2 times 2 minus 1 squared plus 2. All right, following PEMDAS, or order of operations, we have to do what's in parentheses first. Well, 2 minus 1 is simply 1. So that's going to give us 2 times 1 squared plus 2. Again, following order of operations, we have to do our exponents next, which is going to be a 1 squared. So 1 times 1 is 1. So we get 2 times 1, and then drop down the plus 2. Next thing we do is multiplication next, which is 2 times 1 is 2. Drop down the plus 2, and we get a 4. So all that work to get that we've got a coordinate of 2, 4. So I'm going to go ahead and graph 2, 4. All right, that's my plot that point. And now we're almost done. Okay, here is our step 4, and you probably have already guessed it. Our step 4 is going to be to graph the symmetrical point of that green point that we just did. All right, so my step 4 is to graph the point on the other side of the axis of symmetry. Okay, so for example, here's my point right here. Where would the symmetrical point be on the other side of this purple line right here? Okay, well, it would be right here. It's 1 unit away from that purple line. All right, and now we're almost done here. All we have to do is to just graph the parabola. And it's not really a step, although you do have to do it, but you basically are going to just graph your parabola. Okay, so here we go, graphing our parabola, and that's our answer. This is just like graphing a line, but of course our steps are a little bit different. All right, let's go ahead and let's do number 11. Actually, you know what? I'm thinking about this video is getting a little too long. I'm going to make another video so we can do a few more problems. That's what I've decided. All right, make sure you watch the next video. Thanks for watching, guys.